So attempt these following questions. It's a classwork. We have classwork in online classes as well. So the classwork, attempt these questions, send them to my email. For those who need my email, I'm going to just drop my email somewhere here.
Good afternoon, sir.
Good afternoon, ma.
Yeah. You said we should do these questions.
Now, yes, people are doing it already.
Oh, okay. So we should do it in is it Word or?
No, just type like you're sending me a mail.
Mm-hmm.
Yes.
Okay, like I said, that's what I'm saying. We should do it. We are not doing it in our SQL, I think.
No. It's just definition questions and all that. So
Okay. Yeah. Yeah.
late comer, welcome. Welcome. If you can see my screen, right? You can see my screen. There are 5 questions on the screen. And attempt these 5 questions in your email and send them to me via mail. We have 3 minutes to go to doing that. So we're submitting by 5:55. So attempt and send to me now. If you are just joining us, welcome. You have 2 minutes to attempt this question. There are 5 questions on the screen. Attempt them now and send to me via mail in the next 5 minutes. So I'm waiting. I'm in my email waiting for replies. Awesome. Lola, you will make heaven. Awesome. I'm seeing reply from Lola already. Waiting for others. Awesome, John. Well done. Awesome. I'm still replying. I've seen submission from Lola and from John. Waiting on others. I'm waiting on others. Okay. IBK. Awesome. Awesome. Um, getting replies. I've gotten replies from 3 people. Right. All right. Every other person can continue to submit while I continue. Um, right. A good attempt, everybody. Although I'm seeing a few corrections that needs to be made, and I this is why I asked to us to do this so that I can see where the misconceptions are. Please let me know if you can hear me. All right.
I can hear you.
Awesome. Awesome. All right. So I'm seeing a few misconceptions in the results that I'm getting, but so far, everybody that has submitted had a good attempt at it. All right. Well, nice attempt, everybody. Nice attempt. Very beautiful attempt. Everybody that have submitted. I'm waiting for replies from Vivian and Oluwapo and Madam Anita. Patricia is not in class today. All right. So while we do that, let us move into what we have for today's class. I also replied everybody who submitted the last assignment. Kudos to everyone that I got a reply from. You guys are
Mr.
doing.
Show, you didn't reply me.
Lola, I replied you. Are you serious?
You already got the email.
Are you serious? I'll check again. In fact, I think yours was the first I replied. But I'll check. I'll check again. I'll check again. I'll check
Right,
again.
thank you.
Yeah. Right. So apologies for that, but I think I replied. Now that I know that, I'll look at it again. But I replied. In my mind, I thought I replied everybody. I think I replied. I'll check. Right. So nice attempt. Nice attempt, everybody. Nice attempt. If you look at it, you are in less than 4 weeks now. You are not where you used to be, right? You're not where you used to be. You're doing awesomely well with SQL. And that shows you that you can learn a skill as technical as SQL can be in very little time. And I used to tell people that it doesn't have to be stressful or tedious or do you understand what I'm saying? I know what did you say?
So, please, where did you drop the email address?
Okay. My email address is on the screen now. Can you see it? oluwaseun.akin@outlook.com.
Okay, thank you.
Yeah. So, um, Patricia, you're going to pay for coming late,
Sorry,
right?
sir. Good
So,
evening.
don't. I'm going to get my payment on Tuesday. Look at your screen. Good evening. How you doing? There's a white screen on your screen presently. Copy down the questions and attempt them in another 10 minutes while class is going on. Everybody have begin to submit. About 4 people have submitted. Right? It's a class work, so it's not something that you want to wait for. So because you came late, I'm going to give you 10 minutes, 5 to 10 minutes to attempt it. So I'm waiting for your reply in another 7 minutes. Actually, I'll give you 7 minutes to attempt. Right? Attempt all these questions now. Now.
Okay, sir.
All right. Thank you. How are you? So I was saying that it's easier to learn these skills, right? And that is the essence of this training. It's supposed to help you see that learning these skills are not very difficult, right? If you get the right teaching, the right mentorship into it, right? Look at it. What this means is that these are somewhat kind of interview questions actually that I just threw at us, right? Interview questions that are just thrown at us. What is the function of a constraint, right? What is the major difference between the primary key constraint and unique key constraint? What is the function of the alter table state, right? What is a relation and what is a DBMS, right? And you can see that you didn't have to go and read and study and because you were able to attempt it almost immediately, right? In less than 5 minutes, in less than 10 minutes, some people, right? And
Sorry, sir.
yeah,
Please, where do I answer?
in your
Where
email,
is it on your
just
WhatsApp?
like
Okay.
just like you're shooting an email to me.
Okay.
Yeah. So you see, now that means that you are to an extent, right? You're already working as an SQL developer, right? That's what it means. It's as simple as that. There is no two way to it, right? These are of course a bit more. These are questions or interview questions for SQL, right? So, and that is how we proceed. And if you look at it, what I've said it before. One of the major challenges that people usually have in SQL is the constraint part. And look at you, you're all showing constraint as if it is It's rice and beans, right? So I'm really proud. I'm really proud of how far we've come in the few days of this class. I think today marks it maybe day 7 of this class, right? So, and I'm really proud, right? I'm really proud of what you guys are doing, and you can imagine what you're going to do at the end of the program, right? So, if you are there, you can give yourself a round of applause. You're doing well. You're doing well. You're doing well. You're doing well. Please clap. You're the one clapping. You're doing well. You're doing well. All right. I would address the misconceptions maybe at the end of the class, right? I'll address the misconception, but generally, what I think that we need to understand is yes, you understand the concept now. Almost everybody understand the concept now, right? But you also need to understand the terminologies, right? Every field has its terminologies, right? Only a few people were able to put in the right terminologies for in answering the question. And this training is not just to teach you the skills; it's also to help you understand how we talk, right? And like I said, it's an interview question, right? Or they are interview questions, and I wanted you to answer them as um, as somebody who understands the field. Do you understand? Not as just a newbie, right? But I would use some of the terminologies later so that you can understand what I am saying or how you can put it, right? Awesome, awesome, awesome. So, trying to get my slide on. Come on, come on, come on. Right, and if you look at it, right, I want to ask, I want to those two are not really the first time they are meeting me in class, right? Vivian has attended my class before. Tricia the same. Okay, John has been in my class somehow. Okay, let me just hear from Lola and Omolola. I mean, and Lola and Anoluapo, right? So, sure that even though I gave you guys a slide to go through, right, you discover that this training is not really dependent on, it's not heavily dependent on you reading, right? Um, it's not heavily dependent on you reading, right? That means that there's really no heavy materials, heavy books for you to read. It's just explanation in class, you listening in class, and grasping what is saying and what I'm saying, and also on them. There's more focus on being practical, right? The practicality of it. So my question will be that: do you think that this kind of this method helps you learn more, or you prefer the reading method? That's my question to Lola and Oluwapo. Are we there?
Yes. Can you hear me?
Yes, I can hear you. I can hear you.
Well, for this kind of course, I don't think that you can just sit down and read and then understand everything. I believe that hands-on exercises
Okay.
what makes the knowledge stick better. Yes, you can read, but then if you don't practice what you're reading, just have head knowledge, and then you'll be able to practicalize what you know.
Awesome. 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 Thank you. Thank you. I'm waiting on Lola. I hope she's there.
So I'm here. So
Okay.
I think I agree with I know a lot that not reading is not just what it is. Because say for example myself, I have to take 2 days off like my normal work to be able to just not read and practice at the same time. And I'm asking people questions too. I think I actually Mr. Sean like questions when I'm like a little confused. So it's not about reading. everybody can read, and I think studying is what it is. So as you're reading, you're writing, you're understanding, you're googling, and all of that. But yeah, like class exercises also work. Yeah.
Awesome. 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 Thank you for the reply. Thank you for the reply. Um, I know that reading has a place in learning process, right? But I think that presently, um, I'm trying methods of how not to rely heavily on reading, right? I know that as Africans, right, we've been it has been said that we have to read and read. White man said that if you want to hide something from us, put it inside the book. So because of that now, everybody wants to kill themselves with books, right? But then um I'm trying a method, right? And this is the method that I'm trying, which is the class that you are in, and then breaking things down and all of that. And I'm trying to see what is the rate of at what rate do people assimilate these things, right? Is it possible for you to go through technology without every learning technology without having to do every reading, right? Um, and so far, right? So far, I think the method is working, right? Challenge is that I didn't have this kind of um, scenario to learn from, but like I said, Avita's that like I said earlier in one of those classes that we had in the beginning is an heirloom, and we're trying to find the best way to actually pass this down, shorten the time, shorten the program, but make it more interesting and more easy to assimilate and ready, make people build a lifestyle around it. They can believe in, right? You see that now, just 5 questions now, and you're able to attend 5 questions in less than 10 minutes, right? I'm sure that in your mind that will say something to you that yes, I think I'm learning this, right? I think I'm learning it. And if I ask you to begin to create primary key and unique key constraint and create other table statements and all that, it's got that most people would be able to do these things, right? Because and that is out of you not reading or not having to read a very large books. Don't get me wrong. There are plenty heavy books on SQL. I'm not joking. Like I can show you there are heavy books on SQL. Like literally very heavy books. Heavy books. We call them Bible, right? You have a book that is about 2,900 pages on SQL alone, right? And the question would be that somebody who read that book and you who attended this class, would you be able to perform at the same rate? And I put it to you and say yes, right? Because it's one thing to write plenty of books. It's another thing to be able to go straight to the point, right? And most of those books, right? Yes, there's a whole lot of resource in those books and all of that, right? But usually it's just um, beating around the bush and just running around in circles and all of that, right? And that is why we're trying to do this and do this right. So imagine that somebody has an interview tomorrow, right? And you've not even finished SQL, right? And you have an interview tomorrow. It's just about SQL, and they begin to ask you this kind of questions, right? It means that you're going to do well at the interview, right? You're going to do well at the interview. Already, somebody has even gone to an interview in this class, right? In just these few weeks that we've started, right? I will not mention the person's name, but somebody already has gone to an interview, I think last week or so, and she did well, right? The person did well in at the interview just from learning a few things in class, right? I think she even got the job, you see. So just from just having to be in the class and all that, and I just want you to encourage you more to put more time, right? Watch the videos, listen when in class, attend the classes, and you'll see that you do awesome stuff. You do awesome stuff, right? All right. Thank you for coming to my TED Talk. We're done with TED Talks. All right. Today we want to start with creating views, sequences, and indexes, right? Last class we dealt with alter table and all of its variants in um, in last class or in the last class, right? So, and we're still talking about DDL statement, and this is I think this is the last part of the DDL statement that we're talking about. Then we'll move to DML statement. So we've been able to create tables, right? And remember I told you that what tables are not just the only database objects that we have. We have views, we have sequences, and we have indexes. We also have synonym, right? We also have synonym, right? And synonym are not something that we pay attention to, right? Except that you are in an environment where the names of the objects are a bit very long and busy, and you want to create shorter names for them, right? But if you're in the right environment where the database administrator or has set rules and policies that guide object names, and he has created policies that says that you don't have to use descriptive names for your objects, you probably not need synonyms, right? Let me give an honest truth. As I've been working with SQL for about 14 years now, I can't remember creating a synonym, right? Aside from class engagement and all that, right? But in real life scenario, I'm creating a synonym. I can't really remember why. If I've tried to do that before, and the reason is because I'm creating tables, I'm creating views, I'm creating sequences, I'm creating several objects, and I'm giving them short names from beginning, from the onset of creating them. I'm creating very short names. So, and because I'm creating short names, it would not warrant that I have to go and create a synonym for them, right? That is why if you look at this slide, this synonym is not there, right? I mean, in this chapter, synonym is not there but we'll probably just look at how to create synonyms and all of that, right? So we want to look at creating views, right? So remember we said that what? Say that again. Tables are not just the only database objects, right? Tables are not the only database objects. No, we have views, we have sequences, and we have index or indexes, as you may have it, right? So want to start with views, right? So what is a view? That's the question. What is a view? Right? It says views are virtual tables that do not need any data of their own, but displays data stored in another table. The word virtual comes from the fact that they are not real tables, right? Or they are not real tables. They are not tables. They are not tangible objects. Right? That's more like it. That they are not tangible objects, right? Although it does not deny their existence, right? It does not deny their existence. It's just like talking about virtual private network (VPN). Most people are using VPN to access Twitter right presently in Nigeria, right? Now, if you look at it in the real sense of it, actually, VPNs really do not exist, right? You're saying that the network does not exist. That's what you're saying. They are virtual private network, right? But they are not tangible, is what we're saying. It's saying that you're using a clock, a clock to access the internet. That's what you're trying to say. So if you are using a clock to access the internet, what that means is that you do not really exist. You are invisible. That's the word virtual there, right? So invisible, although with respect to views, we're not saying that they are invisible. We're just saying that they are not tangible, right? I mean, they are not tangible. They are intangible objects, right? And it means that they exist, but they do not exist on their own. That's basically what we're saying. They exist, but they do not exist on their own. So views are virtual tables that do not store any data of their own. So you see that they exist, but they do not exist on their own. They are dependent on other objects, other tables, right? It says what displays data stored in other tables, right? It says, in other words, views are nothing but SQL queries, a named query stored in the database catalog. Basically, that's what it is. That's what it is. So a view is an object that is stored on the database for a bit of period. I think we started this chapter last class. I can't remember. I think we started this chapter last class, but don't worry. I'll run through it. I think we talked about indexes. Can you remember? Anybody? Anybody? I remember.
Yes, sir.
We started this topic last class. All right. So I'm just
Yes.
going to explain forward and we're going to move forward, right? So that we don't waste time on it. So that's what views are. So views, like I said, I remember saying last class that we're not going to discuss much about views now because we want to go into DML. Then after we talk about DML, then we'll come back to views, right? So views, like I said, they do not own their own data, but they are created based on data from other objects or from other tables, right? So of course we still use the create view statements to create them. But let's just move on. Then also we talked about indexes, right? We talked about indexes last class. And we said that indexes are used to improve performance of query by quickly finding rows with specific um, um, column values, right? And we talked about the fact that there are two types of queries, two types of indexes. We have the bitmap index and the bit-tree index. Can you remember? And I said that the bit-tree index is a very popular type of index that you would see commonly, or that you commonly see on every object on the database, right? And we also talked about the fact that indexes are created explicitly and implicitly, right? And we said that when they are created explicitly, it means that the user creates them by themselves, right? The users create the indexes by themselves, and implicitly, we say that they are created by the Oracle server, but they are created by the database server, or they're created by the database. Anytime you create a primary key and a unique index, right? I mean, a unique constraint, primary key constraint, and a unique constraint. A unique index is created automatically. It says when you create a table with a primary key or a unique key, MySQL automatically creates a special index named primary key or primary index. Sorry. So this is called a clustered index, and I explained what a clustered index means last class, right? So we talked about index, and we even looked at how to create an index. We talked about creating index using the create index statement, right? And we said that you can create an index when you are creating your table. You can add an index to a table when you are creating the table, right? And yes, you can, apart from the fact that you are creating, when you had a primary key constraint to a column, an index is created. When you create a unique key constraint on a column, an index is created. You can add index to non-indexed columns, right? That are not clustered columns, right? And we also talked about the fact that you can show the index from a particular table. You can see the number of index or the description of all the index on a particular table using the show index from table statement. So you use the show index from table statement to show the indexes on a particular table. Then we also talk about the drop index statement that helps you to drop or remove an index from a table. And I said last class also that when you have a clustered index, a clustered index is an index that is built is like an inbuilt, right? It's inbuilt into the table, right? That is, it is clustered with the table. That's what it means, right? So when you create an index while you are creating a table, what you're building is a clustered index, and that's because you're creating an index through the primary key constraint and the unique key constraint. Now, when you create a table and you have to create an index and add the index to the table, right? Then what that means is that you are creating a non-clustered index, which means that you're building an object from two different objects. You're building an index table from two different objects. You have the table and you have the index. You're now joining the table and the index together, right? That is a non-clustered way of creating an index. What that means is that when you drop the index, the table is not affected. The only thing that is affected is the query performance on that table. When you drop the index, the table is not affected. The columns are intact, the rows, everything are intact, except that queries will not run fast on that table. But when you have a clustered index, right, and you drop the constraint, you drop a column, say you drop the primary key column, right, the primary key constraint will be dropped, and the primary key constraint will be dropped, and the index on that table will be dropped because it is clustered. What that means is that the existence of the constraint and the index is dependent on the existence of that column, right? Because it is inbuilt, right? So which means that when you because you created the index when you're creating the table and it's a clustered environment, right? The constraints and the index do not exist on their own, right? They are existing based on the existence of that column. So when you drop that column, what happens to them? They move. So when you even drop the table, what happens to the constraint and the index? They also what get deleted, right? But unlike in an unclustered or a non-clustered environment situation where the table exists on its own, the index exists on its own, and when you add the index to the table, right, they work hand in hand to make your query performance fast on the table faster. But once you delete the table, the index still remains as an object. Once you delete the index, the table still remains as an object. I hope you understand that, right? And they also looked at how to create unique indexes using the create table and create unique index situation. Then we also talked about composite index, and I told you that you can actually use one single index on multiple columns on your table, and that is what we call a composite situation or a composite index. And we said that you can use as much as one constraint, one index on about 16 columns on MySQL, right? Isn't that beautiful? Which means that you don't have to create multiple indexes and all of that for each of the objects. And the reason why you don't want to create multiple indexes is that they literally do the same thing, right? So why not just create one and multiplex it across what? Across all your columns, right? Multiplex it across all your columns, and it would sort the job for us. Now, if you look at it, we do not really, apart from creating the index, right? Apart from creating the index that we do, and I'm saying human beings now, we do not have any role to play in the way the index performs. Are you following me? We do not have any role to play in the way the index performs. The index performs basically on their own. They perform basically on their own. Anoluwako, please, I see your raising your hand. Please talk to me. Talk to me. Talk to me, Anoluwako. Can you hear me?
Yes. I wanted to ask that what's the primary purpose of this index? Is it just for speed?
Yes, that's their primary purpose, just for speed. Speed for query. Now, what they do is that they help you. I explained the last class. Let me just go back to my board so that you see. I explained the last class. What they do is that they take away the stress of. I hope everybody's done with this so I can move it up like this, right? So you have two scenarios, right? You have what we call an HOT, if organized table. If organized table, and you have what? An IoT, not Internet of Things now, but an index organized table, right? And what you have in this situation is that in an if organized table, right, there is no structure, right? There is no structure to the way the data is, right? What that means is that the system looks at everything in a messy environment. And I gave the example that when you go to university, when you go to your university library, right? If you go to the university library and you discover that the university library is not indexed, right? What happens? And you're looking for a book, it might take you days or months or years to actually find a book. Because imagine University of Ibadan or University of Lagos that has very big libraries, and you're trying to look for a book. It's like you looking for a pin in an haystack. That's what it means, right? But when they are indexed, what happens? They become structured, right? They become structured such that you can say that this is where this is kept, this is where this is kept, this is where this is kept, this is where this is kept. So you don't have to go through the whole data set to look for a particular object. Do you understand what I'm saying? You just go straight to where the object is, and that is why I was explaining some minutes ago now that the only thing that we do with an index as human beings or users of these DBMSs is that the only thing we do is that we create the indexes. Apart from creating the indexes are maintained by this Oracle. Why do I keep saying Oracle server? Right? They're maintained by the database server itself. Are you following me? Indexes are managed and maintained by the server itself, right? Indexes are managed and maintained by the server themselves. We do not, if you look at it, there is no code, right, to saying that you want to manage an index. You cannot, if you alter an index, you're just changing the name of the index, not that you are changing anything that would make the index work faster, because we are not in charge, or we're not in charge of the way they perform, right? I cannot tell the index to say, okay, use, even though by default when you create them on MySQL, what you create is a bit tree, right? It is only in Oracle where you can specify that you want to use a bitmap index or a bit tree index that I know of, right? So in that situation, right, their indexes are managed. I'm just going to put that here. Indexes are managed and maintained by the DBMS, right? So what that means is that if an index is not performing, right? If an index is not performing, maybe the code behind it is wrong, or is faulty or something, right? Indexes are dropped. Hold on, please. This you will not find this that I'm dropping now. It's not common knowledge, right? Indexes. The only thing you can do to an index when you see that the index is not performing, right? What you can do is indexes are dropped, right? When you drop them, what do? You recreate them. That's all. When you notice that the index is not working, it means that the code that is the underlying code for that index might be faulty, right? And you see that the index is not performing. What you do is that you don't say you want to troubleshoot to see why the index is not working. No, because the index are managed and maintained by the DBMS themselves, right? So what you do is you drop the index. Once you drop the index, you recreate the index, you attach the index back to the table, it begins to perform. Do you understand what I'm saying? So that's the way they work. They are compiled by themselves. They are compiled and recompiled by the DBMS themselves. That's basically how they work. I hope I answered your question, right? So that's what we do with indexes, right? That's what we do with indexes. All right. So composite index, yes, you can use composite index. Now, drum rolling. Today we're starting chapter 5. Chapter 5, and we have 7 more chapters to go, but these are more interesting and very fast chapters that we're going into, right? So we have done DML statements, right? The DML statement, what we have done so far is that we have looked at the create statement, right? We looked at the alter statement. We looked at the drop. We looked at the rename. We've looked at create, alter, drop, rename, truncate. Right? The only one we've not seen is comment. We'll talk about comment much later. Right? So basically, this is all that we have in the data definition language. Ladies and gentlemen, you are a professional in data definition language as of now, right? So we'll look at how to create sequences and synonyms much later. But like I said, and also views, right? Because views is dependent on the chapter that we want to talk about right now. That's why I'm not talking about views, but that's why we're only able to talk about indexes now. So we'll talk about sequences. Sequences are not very complex as it's just something you create. It is also maintained by the DBMS server itself. Sequences are also maintained by the DBMS servers themselves. So they are automated programs, right? All right. Now let us move on. So today we want to start with data manipulation language. That's DML statement. Now, I'm not going to say that I'm the only one who teaches SQL and teaches the full SQL, right? But what you have in most courses that you have online, right, is what we call CRUD, right? That's what you have in most courses that you have online, especially courses that where they say they want to just touch SQL. When you hear they want to touch SQL, basically what they say is that they want to touch CRUD. What they teach you is CRUD. So, and when they say they've taught you CRUD, they say that they've taught you SQL, and you can see it. There's more to SQL than this. But I'm going to explain what CRUD means to you. CRUD means create. Create is for C is for create. R is for read, which we will talk later. We'll talk about later. U is for update, and D is for delete. Right? Right? And imagine out of 13 programs or 13 languages that are possible or 13 statements that are possible, we're only doing 4. Right? Right? And that is why we say that at Avita we try to teach all that is necessary for us to teach, right? So we're not going to just do crude, right? We're only doing crude and all of its members, right? And now, why did I go to crude, right? Crude is basically, it has more of DML than DDL in it, right? Because read is DML, U, which is update, is DML, and delete is also DML, right? So the question is, why do they do crude, right? What they mean is that you're just only supposed to work with the data inside a DBMS, inside a database, right? You're not supposed to be able to create objects in the database, right? You're not supposed to be able to create objects in the database. You're supposed to just work with tables in the database, work with already created tables, right? And that is why that's why this training goes beyond all of that, right? And you've seen that what we started with is creating, and altering. Structure of the database, creating the database, creating tables, creating and all of that, right? So now we want to talk about working with the content, right? Working with what is inside of your table, what is inside of your table. So the first data using SQL statements, right? SQL select statements, right? So how do we retrieve data in SQL, right? We use what we call the select, right? So think about select, like I said, right? These things are English language, right? And if you understand English language, if you understand English language, what you have done is that you understand SQL to an extent, right? About maybe 40, 50, 60%, right? And think about select as you want to go to the you entered into a store, right? And you want to buy a dress or you want to buy a shoe, right? What do? You look at everything they have in their catalog and you pick one thing, right? How do you pick? You select. You say that I want that shoe. I'm selecting that shoe from, and if you look at those kind of stores, of course, if you look at those stores, not all these stores where they mix things together. But discover that in those stores, they what they do is they index their objects, right? They index their shelf. This is where the clothes are. This is where the shoes are. These are where the accessories are. These are where the bags are. These are where the leather works and all of that, right? And what you do is that you go to a section, right, and you pick what you want from that section. Same thing that we do at ShopRite or the shopping malls that we go to buy groceries, right? You go to those grocery stores, and when you get there, you go to a particular section. And in that section, what do? You select what you want to buy from that section. I hope you're following me, right? So select is the statement that helps us to get stuff out of the database. Now, when you say you select, what you say you're doing, I've said it before, is that you are writing or you're querying the database. You query the database, right? So we say that Anita, as it were, she's the data expert in XYZ company, right? And she wants to get an information from the database. What does she do? She writes a query to the database, and the query returns her a result. She writes a query, she gets a result. Basically, how it is done, right? That is how it is done. So, select statements retrieves information from the database. It's as simple as that, right? And before now, like I said, SQL exists in dialect, right? SQL exists in dialect. And the dialect that we're speaking presently is that before now, SQL was part of the DML statement, right? Even most literatures still have it that way, right? Most literatures still have it that way. Inside the DML statement, what you have before now is select, insert, update, and delete, right? This for statement in Oracle, right, we have what we call merge, right? Merge is insert plus update, right? Merge would do insert plus update. So this is peculiar to Oracle, right? Just trying to show you what is possible. This is peculiar to Oracle, right? And we don't consider merge as an SQL statement because it's not universal. So it is not, I'm just showing you what Oracle has and why they are number one in the market, right? Why they are the grandfather in the database business. All right. So select, insert, update, and delete are the DML statement. But in recent times, right, what we have discovered is that select does not manipulate the data, right? So it does not qualify to be part of the DML. So we call it they created a different part for it, which is called DQL, data query language. Right? So under the data query language, what you have is, ladies and gentlemen, you have select. So what does that mean? That means that you have select not being part of DML statement, right? But note, right? If you have an exam or you have an interview and they're asking you to talk about DML statements, right? You can mention select as part of the DML statement, right? Because it is basically part of the DML statement. But if they now ask you that, is it really a DML? Actually, if you're doing an interview with me, that would probably be the kind of questions I'm going to be asking you. Say, okay, differentiate to me, or explain to me the DML statement, right? Explain to me what the DML statements are, and you begin to name select as part of it, right? Yes, it is. You score a good mark for it, right? But I would question you more to say that, are you sure that select is still or is a DML statement? Well, how does select manipulate the data, right? How does select manipulate the data? And in this real sense of it, select does not manipulate the data, right? Except that the only thing that it does is that it queries the data. Select queries the data, and that is why some literatures or new knowledge says that it is the only statement in the data query language, right? It's the only statement in the data query language. So having said that, right? So select is data query, right? It's DQL. Select is data query, but also some literatures will say that it is DML, right? But irrespective, right? So now select helps us to retrieve from the database, right? Retrieve information from the data. Basically, that's what it does. Basically, that's what it does. Basically, right? It helps us to retrieve data from the database. Now, select has three main criteria that it does, or three main functionality. Sorry, functionality. Three main functionality. Three functionality. Right? The first one is projection. That is, with select, we do projection. The second one is selection, of course, retrieval. Selection or retrieval. And the fourth one is joining. So you can call them PSG. No, PSG. Right? PSG, not PSG. PSG. Right? So projection, selection, and joining. Now I want you to look at this part of this table so that I can explain what these three guys mean and how does select what role does select does, right? Remember I said that select helps us to retrieve data from database, right? Which means that we send a query to database. The database gives us a result. Now, when we talk about projections, right? So the question is, what is projection? Projection is select the columns in a table that that is returned by what? By the query. That's basically what it means. Don't mind the plenty English that is there. Select the column in a table that carries or that are returned. Sorry, not care, that are returned. I need to edit some of this, guys. I wrote them in a rush then. Right, that are returned, right? That are returned by a query. So select a few or as many of the columns as required. Now, basically, that's plenty English. What do we do with projection? Projection is that we are selecting columns, projection goes with columns. On your table, right? So you do projection on your columns. Are you following me? I'll say that again. You do projection on your columns, on the columns of the table. Projections are done on the columns of the table. If you look at this scenario here, we are selecting these two. This table has 1, 2, 3, 4, 5 columns. We are selecting two purple, two columns, right? Painted purple. And if you go by the ash ones, so we're saying we're selecting what? 3 columns, right? So we do projection. Projection helps us to select a number of columns from a table. That's basically what it is. Selection, on the other hand, is performed on what? On rows. Remember that a table exists in rows and columns, right? Table exists in what? In rows and columns. So we do projection on the column. We do selections on the rows. So select the rows in a table that are returned by what? By a query. Various criteria can be used to restrict the rows that are retrieved, right? So basically, we do selections on the rows. And when we say we join table, right? We join table, we can use SQL select statement to join two or more tables together, right? To give us more information. It says bring together data that are stored in different tables by specifying the link between them, right? By specifying the link between them, right? So that is what we do with joining. Joining is that I have data across 3 tables, and if you remember the class where I discussed extensively the ER diagram, and I told you that you're trying to get a full information about somebody, right? You get the information from you're trying to get full information maybe about an employee, right? So you get the information from the employees table, the departments table, the locations table, the countries table, and so on. How do you do that? You join them together. You join the tables together, right? And how do we join these tables together, right? That's where your constraint comes in, right? Constraint plays a good role in your primary key and foreign key. Plays decent role in joining, right? They play decent role in joining. Remember, we said that foreign key, a primary key is when the primary key is referenced to another table, it is called a foreign key, and because of that, it becomes a pointer to a table, right? And because it's the pointer, we can use that avenue to that pointer to get more information about that information that we're looking for. So that is what we do with the select statement. Select statement does 3 things: projection, selection, and joining, right? And let us look at how to write a select statement, right? How do we write a select statement? Select statements are very easy to write, right? So don't think they are hard. Give me a minute, please. A minute. I'm back. Sorry, just was feeling thirsty, so I had to get something to drink. Sorry, I'm back. All right. So how do we write select statements? That's what we want to go through now. How do we write select statements? Right. And like I said, select statements are easy to write. Right. There's a syntax to write select statement, and this is the syntax for writing select statement. Right. So we say select Can you see? Select, and you have a select list, and you say from. Where are you selecting from, right? Like I said, when you want to buy something from a store, the stores have all these sections, right? You go to the section and say, or you go to the whoever sells and say, I want a Nike shoe from from the shoe section, right? Or I want a Zara from the shoe section, or I want a reclined shirt from the shirt section. So you're selecting from a particular table, right? So there must be the select keyword and there must be the from keyword, right? The select keyword and the from keyword, right? If you have a younger one at home or you're trying to send somebody, maybe a maid, your younger one, maybe a friend or something, say, hey, help me bring a help me bring water, right? And say, where do you want me to bring the water from? Say from the fridge, of course, right? And if you don't want cold water, you say, okay, you can bring it from the store for me, right? There must be a location where the data is stored that you want to get that information from. Please let me know if you can hear me.
Yes, okay.
I can hear you, sir.
Awesome.
Hey.
Awesome. All right. So we say select identifies the column to be displayed. So in the select part of this whole statement, right? So remember we said that what it does, select statement does projection, selection, projection, and joining, right? So I'm going to pull out joining for now. So we just want to concentrate on select and selection and projection. So the question will be that where do we do selection? Remember we said selection, projection is based on the columns of the table, right? So the first thing we do when we're writing a statement, when we're writing a select statement, is that we use what we say select. That's the keyword, right? And with this select actually is what we use to do the projection. This select keyword is what we use to do the projection, because what we need to do after the select is give this select a list of columns to retrieve. We give this select, are you following me? This select, we give it a list of what? A list of columns to retrieve, which is what we call the projection, right? We project with the select. Then from, right? From is now from which table, right? From which table are we doing this what? Projection. From this table, from which table are we using to projection? We give what? We give the table what? The table name. Right? Give the table name, right? So it says from identifies the table containing those what? Those columns. Can you see? Right? So look at an example here. We're going to go to SQL now, into my SQL workbench. We're going to see an example. Say displaying all the data from a table, right? It says select. Can you see select asterisk from department? So take for example, right? We call some things wildcards. Wildcards, right? Right? Wildcards. And the first wildcard that I want to introduce to you is the asterisk. Asterisk, right? And anytime you see an asterisk in IT, right, in programming languages, what it means basically, if not explicitly specified, what it means is all. Are you following me? I'll say that again. When you see an asterisk in a programming language, except another meaning is given to it, right? Except another meaning is specifically specified for it. By default, what it means is all. All. So we use it in SQL, we use it in Python, we use it in R programming, we use it in Java, we use it in most of the programming languages that are available, right? It means all. Of course, in some occasions, right, it carries a different meaning, right? It carries a different meaning. In some occasions, it carries a different meaning. Even in these programming languages that I've mentioned, as much as it is all, in some situations or in some use, right, it will not mean all. It will mean something else. But most cases, right, it means all, right? Now, when you say all in SQL, right, when you're talking about database and you say all, right, and you use these asterisks with the select statement, what you are saying basically is that I want you to retrieve all the what? Columns and all the rows from this table. I'll say that again. When you see all, that is the asterisk, with the select statement, right? What you're saying is that I want you to retrieve all. Remember we said that what? This asterisk means all. So you're saying retrieve all the columns and all the rows. Retrieve, I'm doing a total projection on all the columns and a selection on all the rows, right? Retrieve everything that the table has. That's what you're saying. Retrieve everything that the table has, right? So basically, right, we want to see a few examples, right? Plenty story that I've been saying. Let's go into the workbench so that I can show you a couple of things that we want to talk about or that I've been talking about, right? Please let me know if you can see my screen. Right. So all right. So today I'll be using two tables or two schemas. Can you follow? Are you following me? I'll be using two schemas. Please let me know if you can hear me and you can see my screen.
Yes, I can hear you.
Okay. Okay. Awesome. Right. So I'll be using two schemas. Am I still recording? Yes, we're still recording. I'll be using two schemas today. I'm going to start with the classic model, right? So I'm going to say use classic model, right? This is it. I'm saying use classic model, right? Can you see just by typing the name classic model, the data has been activated. So I'm just going to say classic models, right? So I'm going to use that as my database, right? Can you see? I have told you that anytime you use a database, what happens? It gets extended. So now I want to see all the tables that this database has, and I can see that it has quite a number. It has customers, it has employees, it has office, it has um, order details, it has orders, it has payments, it has product line, and it has product. I hope you can see what I have there. I hope you can see what I have there, right? So it has those tables, right? So I want to, first of all, I want to use the customer table. So this is our business case now, right? We have a business case that says that generate a full report, right? Generate a full, when you see something like this, generate a full report. Generate a full report of all, generate a full report of all customers, all the customers of the company, all the customers of the company, right? Generate a full report of all the customers of the company. That's the business case that we want to attend to. So the business analyst or the business manager came to tell you and say that SQL developer Noluapo, right? I would like to get this information. I'd like you to help me generate a full report on all the customers of the company. So the question will be, what would you do? Don't go and say, yeah, pal. I don't know what to do. No, it's easy, right? When they say generate a full report of all the customers, right? So you want to say, remember I've told you, whenever you have a business case like this, what you want to look for is you look for the keywords in your in that business case, right? So you look for the keyword, the full report. So you look for the keyword full report of all, right? A full report or a report of all the customers, right? So this is a keyword, right? Of course, we're generating a report that is of all the customers. So of all the customers, which is that we are the subject matter here are the customers, right? So where are the data of the customers stored? We look at here, we have what we call the customer what? database, the customer table. Inside classic model, we have the customer table, right? What does that mean? It means that first thing I'll probably do is describe that customer table so that I acquaint myself with what I have there, right? I acquaint myself with what I have there. And I told you that the describe function or the describe word helps you to what? The describe would help you understand the structure of the table, right? We describe, we see the structure of that table. So when I run customers, right, it will give me the structure of the table. Now, what you have as that result is the structure of the table. Now, in seeing the structure of the table, I can see the way they wrote the names. Can you see? The first name starts with a small letter and the next one starts with a capital letter. So I can see the field name, that is the columns. I can see the data types. I can see the null value. I can see the primary key and so on and so forth, right? So there is only 3 columns. Okay, only 5 columns allows for no value. How many columns does he have? It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 columns altogether. So this table has 12 columns altogether, right? It has 12 columns altogether. So now that I understand the structure of the table and I want to generate a full report, all I would just say is select, right? Keywords are going to come out in blue, can you see? And there's IntelliSense. Keywords will come out in blue. So select all, right? Asterisk. Select all, can you see? From another keyword, right? Another keyword. Also, when you're writing your statement statement, I've told you this before, separate your keywords, right? Separate your keywords on different lines so that your code can be readable. I can actually write all of them on the same line. It will still run, right? But for readability, right? Select, we'll put them on different lines for readability. So from, what's the name of the table? Customers, right? So yeah, what I'm doing is that I'm generating a full report of all the customers, right? So from the customers, when I run that, it gives me all the details of all the customers. Are you following me? It gives me the details of all the customers. And what does that mean? This table has one. Oh, look at it. I want you to look at this place, right? Look, can you see my cursor, please? Follow my cursor, right? Look at it. It says that select all from customer, limit 0 to 200, right? And it's telling me that this query is telling me that how many rows? 122 rows are returned. Of course, the time it took to also run that, but we're not bothered about the time. Of course, just about 1.5 seconds is what it took to run that statement or to process the statement. So the table has 13 rows, like I mentioned before, although I said 12, 13 rows. The table has 13 rows and 13 columns. Sorry, the table has 13 columns and 122 rows. What does that mean? It means that the dimension, I've said that, I've taught you this before, right? The dimension of the customer table is rows 122 as rows multiplied by a column. That's dimension. 122 multiplied by what? 13, right? So this will tell you the number of data sets, the number of rows, cells that are in that table. So we have 122 rows by 13 column, right? So it's just so that we understand, right? So look at it now. You have customer name, customer number, customer name. Customer last name, customer first name, phone number, address line 1, address line 2, city, state, postal code, country, sales rep employee number. That is, who is the person servicing this customer? Who is this person serving this customer, right? And credit limit. So What does that mean? If you look at it, right, who can identify, look at this data that you have here, and identify from all of these columns, which column is a foreign key here? Which column is the foreign key here? We have customer number, customer name, customer last name, first name, phone number, address line 1, address line 2, city, state, postal code, country, sales rep, employee number, and credit limit, right? Which column here would be a foreign key or is a candidate to be a foreign key? Who can tell me?
I think sales rep employee number.
Yeah. Absolutely. Right. That you're right. Sales rep employee number. This column, and why? The reason is because it contains just number, which did not tell us or does not tell us plenty things. What it means is that it is telling us that there is more to these numbers. There are more to these numbers. These numbers represent somebody somewhere. So we have to be able to want to know more about this table or about this number. We have to look for the table where these numbers are coming from, right? Then you can see their credit limit and all of that. This is what we call a full report on the table, right? A full report on the table. Full report on the table. I hope you understand. Right? I hope you understand. Right. So that is how to write. So there and there you've written your first SQL statement. First SQL select statement. Sorry. First SQL select statement. So we can now take it next to the next level. It says this can also be written as, now going back to that, right? So what if, so the question will be that, what if I do not want to return all the columns and all the rows? But let's even just stick with all the rows yet. I just want to know the names and number and phone number of this employee. So the business manager came again and said, beautiful reports that you have generated, but I want you to help me generate. Apparently, I do not need all of these information that you have given to me, right? I just want you to help me generate basic, right? Let's just start with the word basic information about the customer. Basic information about our customer. Sorry, why did I do that? Basic information about our customer. I say, oh, okay. I can do that. I can do that. What do you, so you say, what do you need? I probably just need their names, their phone number, maybe the state where they stay, maybe their credit limit, right? That's all. That's just what I need, right? That's what the person says to you. So, okay, all right, we'll get that in 5 minutes. And you come back to your SQL workbench and you say, okay, basic information. Basic information, what am I going to do? So I'm just going to say select, right? So you say, I'm going to select their customer name, customer name, or let's start with customer number, right? Customer name, right? Customer last name, right? Customer, okay, sorry, it's contact, not customer. Contact last name. Contact last name. I'm going to copy this. Say contact first name, comma. You separate each column by a comma. Phone number. Sorry that I didn't mention that early. Select each column by a comma. The state, and or okay, let's leave state. Phone number and credit score. Credit limit. Sorry. From what's the name of the table? Customers. Right? Now look at it. If I run this statement, you select everything and you execute. right? Can you see? The table, what we've just done is that we've done another kind of projection, right? Remember, we're still talking about projection. What we just did is another kind of projection, right? This time around, we're not using the asterisk all, right? We are selecting the columns that we want, which means that we can have a table and not want to see all the data at once. So we select what is needed from what? From the column, and that is what we call projection. And we say from what? From a customer. So in this situation, we say customer number, customer name, contact last name, contact first name, phone number, and what? Credit limit. Can you see? That is what we have here. So you can see artillery, Grafiki, sheetmates, Karen, phone number, and all of that, right? And you have all of that about the customer and the contact name, right? And if you look at the data here, the customer here they are majorly company names, right? They are majorly company names, right? Because probably this database is a B2B business, right? It's for a B2B company, business to business organization, right? So their customer usually are just the customers are the respective companies that they work with, but then they now have the contact person for each of those companies. That is what this data is saying to us. That's what this data is saying to us. So you can see West Coast Collectibles, the person they have there that is the contact person is Thomas Steve. Thompson Steve, whose phone number is this, his credit limit is this. Warburg Exchange and Volvo model replicas, Vitachrome, and so on and so forth, right? You can see Tokyo Collectibles and all that. So you can see that that is what the data is all about. And you can really understand and easily understand what the data is about. Are you following me? So this is how to do a projection. This is how to do the projection. It says it is important to know. So, all right. It says we can also display specific columns. Right. This means we can project a few columns instead of displaying all data from all the columns, which we just did. This is important to note that MySQL evaluates the from clause first, then the select clause, right? So how does the system or how does the server, the MySQL server, how does it evaluate, right? Now, what it does is that it does not go looking for customer number first, right? Because it cannot look for customer number when it has not gotten the table that is the data is supposed to come from. So SQL would execute the customer from clause, this from clause first. What it's saying is that what am I looking for? Or where am I looking for what I'm looking for? Oh, what I'm looking for is inside customer. So it looks for the customer table first. When you have that, then you now begin to look at what? Look at the columns of that table. Right? So you ask your younger brother or your maid to bring you oranges, right? Where would she look? She'll probably go to the kitchen or probably go to the refrigerator, right? Now, she will not, first of all, be continue to look for me. She will not go in search of the orange initially. Of course, what she's looking for is the orange, but the first place she's going to is where do we keep oranges in this house? Is when she gets to where we keep oranges in the house, either in the fridge or in the storeroom or in the kitchen, that she now does the selection. So you see that it is basic logic and English. Are you following me? Right? So all right. So we want to see arithmetic expressions with select statement. Arithmetic expressions with select statement. It says data can be modified using arithmetic operators in select statement. Using arithmetic operators on columns can create an expression such as calculations or look at what if what scenarios, right? Basically, what we're saying here is that there are some columns, right, that you have on the table that we can perform arithmetic expressions on, right? We can perform arithmetic expressions on those columns. And when you talk about arithmetic expressions, what kind of arithmetic expressions can we perform? We have addition, we have subtraction, we have multiplication, and we have division. As examples of what we can do, as examples of what we can do. Please let me know if you are following me. Please let me know if you are following me. Hello?
We're following, sir.
Yes, I am. I'm following you, sir.
Awesome. 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 Who else is following? Madam Anita, are you following me? Lola, are you following? Any questions so far? Vivian,
Yeah.
Sir,
any questions so far? Anybody?
yes, sir.
You have a question?
Yes, sir. Can
Okay.
from the first select from all, can you select a database or a schema?
Can you select a database or a schema?
Mm,
Okay. So now, beautiful question actually, right? Now, say that say that which is one of the challenges that I have with my Microsoft SQL, right? Yeah, Microsoft SQL, right? If I am in a schema, if I'm a user of a schema, right, I do not need to reference the schema anymore. Are you following me? If I'm a user of a house, so take for example, I'm in the house. Let's assume that I'm in my house and I'm a user in the house, right? Do I need to say that I'm going to my house to go and get orange? No, no. I'm in the house already. Where am I going to? I'm going to the refrigerator to get a drink, right? But Microsoft SQL does not look at it that way, right? So take for example, if it was Microsoft SQL, we're going to be writing the statement as something like this: select all of these, copy, right? Say this, they will say dot. What's the name of the table? Classic models dot customers, right? Classic model dot customers, right? Now this is a full referencing of the table. We are saying that the classic model, the customer table of what? Of the classic what? Classic model, right? But know that you will not be able to use this table if you have not activated the model, right? Which is why in the beginning, I mean the schema, which is why in the beginning, what did we do? We say use what? Use classic model so that what? So that there won't be confusion. What does that mean? It means that if another database on my schema, right, probably as customer, right? Let's say that maybe in HR, I have a customer table, right, which I do not, right? But let's assume that I have a customer table there, right? There won't be mix up. That's why I said what. That's why in the first instance, the first thing we did was use what? Use classic model. So which means that if I want to use the customer in HR, what do? I'll say use HR. Are you following me? Now, but to answer your question, yes, you can reference uh, your schema name, right? You can reference the schema name in using the database or using the table. You can reference the schema name. Now, situations where we do that also will be that maybe you are in an environment where where what you have is so take for example, these schemas now becomes users, right? These schemas become users. So let's say that this classic model is Vivian's table, right? And yeah, TT has a table called TT's table, right? And okay, I think Vivian, okay, this is Vivian and this is TT, right? Vivian wants to use TT's table and TT wants to use Vivian's table, right? In that situation, each other's table. I've showed us this before, right? Let's assume that this table is inside VVDev's collection, right? Now, what that means is that I would say that, and I am TT. I want to use Vivian's table, right? So I'm just going to say I have to reference the owner of the schema. Can you see Vivian Devs dot the name of the table customers table. Right? Now, this is me running this statement not as what? As Vivian, but as a external user to that schema. That's the only time that you're supposed to reference the name of the schema dot the what? The table. Right? But this is how we reference it. I hope I answered the question.
Yes, sir. Thank you very much.
All right, awesome. Any other question before I move on? John, ask me a question.
I don't have any question.
You don't have any question. All right. Just wanted to know if you're listening. Awesome. So we have done. We have seen how to select a table. Don't worry, you're going to be doing beautiful assignments on this. So once we look at how to perform arithmetic operations, so we can do arithmetic operations on this table, right? It says when arithmetic operators are applied to columns, an expression is generated. I'll take that again so that you know. When an arithmetic operator is applied to a column, that is when you apply addition, subtraction, multiplication, and division to a column, what do you generate? You generate what we call an expression. You generate an expression. You generate an expression, right? It says this expression as well generates a what we call a pseudo column for the result of the expression. Don't worry, I'll show you all of that. Then it says you can use arithmetic operators in any clause of your SQL statement except the from clause. I'll also explain that. It says with the date and timestamp, date and timestamp data type, you can use the additional and subtraction operators only. Of course, you cannot divide a date and you cannot multiply a timestamp. We'll talk about all of that. Let me go back into my data. Right. So I'm just going to write another statement. Right. Let's look for a business case. Right. That says that. Okay. Let's go into another schema. Right. Let's go into another schema. Let's say that we want to use the HR schema. Awesome. Let's use the HR schema for this now. So I'm leaving the classic model schema.
Sorry, sir.
Yes.
From the what you just finished referencing at the line 14 from customers, you didn't put the semicolon and then it still worked.
Yes, on Microsoft Workbench, semicolon is optional. Do you understand? Semicolon is optional on the Microsoft Workbench. It is in the command line that it is compulsory. Do you understand? Do you understand? So I can write my statement in this place without putting a semicolon at the end like this, right? Semicolon at the end is a delimiter that it signifies that this is the end of that code, right? So, but in MySQL on this workbench, it is optional. But in the black and white command line interface, it is compulsory. Does that answer your question? Vivian, does that answer your question? Person I'm explaining to has left class. Vivian, did you hear what I said?
Oh, sir, network cut out.
Right. So I'm saying that we use the semicolon to end the to signify the end of a code or a statement, right? It's called a delimiter, right? But in MySQL Workbench, it is optional. I can run the statement without the semicolon, right? But in the command line interface, it is compulsory that you terminate with this command line. I mean, with the semicolon delimiter. But in this place, it is optional, right? Awesome. So I said I want to use HR. So I want to use HR schema, right? Using the HR schema now. And inside the HR schema, I'm very familiar with this schema, right? I want to use the employees table. So I'm going to say, we say generate generate a report of all the employees, right? So you say select all from employees, right? If I run this statement now, what happens? It will generate what? Jesus, did I delete the data inside this table? Lord, when did I do that? Okay, don't worry. I deleted the data in that. All right, so I say department. Let me see. I hope I've not deleted what? All of them. Okay, just give me a minute. All right, I just deleted that schema. Hold on. I need to open a script. I need to open a script very quick. Give me a minute, please. I gave us the script. I want to believe we've opened it. Give us the script. I'm going to open HR. All right, this guy has everything that I need. Just going to run all of this at once. Be done in under less than 1 minute. I'm running multiple SQL statements at the same time. That's what you're seeing. You see that it is going by itself. That's what you're seeing. What I'm creating is a full schema. Creating a full schema. It will be done very soon. Just want it to finish so that we can use the data inside of it. Can you see the way I'm adding my foreign key? Can you see? I've created the tables, I completed the tables, I put data inside the tables, then I added the foreign key. I'll explain that later. I'll explain that later. Almost done. Almost done. Yeah, I think we're done now. All right, we're done now. Done. All right. So if I reload this now, you see that I have HR schema now. Can you see? I have HR schema. All right. So I dropped that schema. So I say use HR now. Let's use HR again. All right. So we're inside HR now. So I want to use the employees table. So I say describe employees. The employees table contains information about the employees, right? Can you see? So it gives us a full description about the employees. I have 11 columns in that table. Of course, this result gives us 11 rows, but what it means is that we have 11 columns on the employees table, 11 columns on the employees table. So you have the employee ID, the first name, the last name, the email address, hire date, job ID, salary, commission percentage, manager ID, and department ID, right? Can you see? All of these are foreign keys. This is a foreign key, this is a foreign key, and this is a foreign key, right? Foreign key constraint. Also, now that we have that, so if I say select all from employees, select all from employees, we have, right, gives us the full information about the employees. Can you see? Full information about the employees. We have 107 rows on that table. 107 rows on that table. That's the dimension of it. So the dimension of the table is 107 rows multiplied by 11 what? 11 columns. 107 rows multiplied by 11 columns, right? That's the dimension, right? No, so we can now do projection and say that we just want basic information. Same query that we ran earlier. We want basic information about these employees. So what do? We say select first underscore name, last underscore name, email, phone underscore number, and the salary from what? Employees. Can you see? Right? So what do we just do? What we're doing is that we're doing a projection. Can you see? So out of 11 columns, I'm just interested, for this query, I'm interested in just 5 columns. Out of 11 columns in total, I returned what? Just 5 columns. The first name, the last name, the email address, the phone number, and the salary column, right? So it's as simple as that, right? So when you want to do, now, of course, we're approaching December, right? We're approaching December, and the company wants to know, right? The company wants to know, generate a report of, adding $500 to every employee's salary. Generate a report adding what? $500 to every employee's what? Salary, right? So the company wants to do a bonus of 500, but they want to know how much it will cost them if they are to increase or give a bonus of $500 to every employee, right? Right. So they ask you to generate a report. What do you do? Right? I've told you, generate a report, adding. Can you see the keyword is there? Adding what? $500, right? Adding $500 to what? Employees table. What part of the table? The salary column of the employees table. So what do? We use our select statement to say that what to use. We want to see the employee ID, employee underscore ID, first underscore name. Please follow me. Last underscore name, right? Salary, and salary plus 500, right? Salary and salary plus 500. Are you following me? Now, can you see? So, if you look at it, first of all, the salary column is an integer column, right? That means that it is only this column that we can do an arithmetic operation on. That is, this column data type is, can we add numbers? Can we add number and says, of course, it would not make sense if we had 500 to the employees column, even though it's a number column, right? The employees ID, you don't have to increase it, right? Can we add 500 to the first name? No. Can we add 500 to the last name? No, right? So the only column that on that table that of course, phone number as well, we cannot do that kind of arithmetic operation on the phone number column, right? So the only column where we can do this kind of arithmetic operation is this what is the salary column, which is what's numeric. So if I run this code, what do I get? From what? Oh, I'm not finished. From employees table, right? So if I run this now can you see? So you see that it gives me for every column in my projection, right? It gives me a corresponding result: employee ID, first name, last name, salary, right? And they gave me a column that is salary plus what? 500. Now you see this salary plus 500. It is not a real column. It is what we call a pseudo column. Let me show you. It is a pseudo column, that is a false column. That column does not exist. And what is the reason why it does not exist? Because it is created based on using a column with an arithmetic operator which generates an expression. That column that you see there is just an expression. It does not exist, right? It is not part of the column in the table, right? This column is generated based on what? Based on this expression that you have there. This is what we call the expression. The column is generated based on what? Based on the expression salary multiplied by what? Salary multiplied by, salary plus what? Plus 500. Are you following me? Right. So that is what generated that column. So we call this an expression. It is a pseudo column. We call it an expression. Are you following me? Right. So let me go back to the slide. So it says you can what? Use an arithmetic operator in any clause of the select statement, except for what? For the from clause. Of course, we cannot use an arithmetic operator in the from clause. We cannot say from employees plus 1,000. Are you following me? We cannot say from employees multiplied by 5,000, right? We can only do that we can do arithmetic operators in every word, in every keyword of the statement, except from what? From the from clause of the statement. Lastly, it says, of course, when we talk about date and timestamp, we know that the only thing that we can do with date and timestamp is what? Addition and subtraction operation. We'll look at all of that as we proceed. Right? We'll look at all of that as we proceed. So basically, that is an expression. So now look at the examples of these expressions. Select employee ID, first name, last name, salary, job ID, salary plus 1,000. From what? Then department ID from employees. This is an expression. Salary plus 1,000 is an expression. Look at this one. Select employee ID, first name, last name, salary multiplied by 12 divided by 5. From what? From employees. Salary multiplied by 12 divided by 5. Then department ID from what? From employees. Then look at this one. Select employee ID, first name, last name, salary minus salary multiplied by 12 divided by 5. Then department ID from employees. So you can perform all kinds of what? Arithmetic expressions. Right, let's see. So select. Let me just copy this. Right.
Sorry, so does this mean that you're creating a new column?
Yes, can you hear me? I can hear you. Hello, sir. I can hear you.
Okay, I'm saying since you didn't create this this select salary plus 500 initially, does this, and then from the select statement you're selecting, you're selecting it, does it mean it's okay that you're creating it? Is it recorded? Is it there? Is the data entered?
No, the data is not entered. It's like I said, it is a pseudo column. Pseudo as in false column. It is only there based on this expression, right? Select statement does not have the ability to insert into the table. So it is just for reading and for report sake. right? If you go back to the table, right, look at it. If you go back to the table, describe employees, right? If we describe employees, right, you will see that there is no column called salary plus 500 there, right? There is no column called salary plus 500. So this is just a pseudo column that is used for what? For analysis and report sake, right? For generating report and probably for analysis, right? And it is not stored. This result is not stored. This result is not saved. We'll talk about how to save this kind of report much later, which is where view comes in, right? Which is where view comes in, right? So, but this report is not what is not stored. This report is not stored. It's only generated based on this expression, right? And I want to create more expressions. So it says salary multiplied by 12, right? You run this now, right? What you would have is, can you see, you have two expressions now. We have the first expression as salary plus 500, and we have salary multiplied by what? By 12, right? We can create another expression to say that salary plus 500, right, multiplied by, hold on, I'm going to use this to teach you this, right? So salary plus 500 multiplied by what? 12. Right. Now, before I run this statement, who can tell me what this would do? Who can tell me what this would do? How would this be evaluated? Salary plus 500 multiplied by 12. What do you think the result is going to be? And do you think the result is right? I need somebody to answer that question. It's just mathematics.
It will multiply salary.
Okay.
Multiply the salary plus 500 table by 12. Each of
By
them by 12.
Say that again. Say that again.
I said it's going to multiply the salary plus 500 table column. Sorry, the column by 12. Like it will multiply the figures on the column by 12.
Okay, good.
And then create a new column for it.
All right. So what you are doing is that what I'm doing here is that I'm saying that, of course, this can be a business case or anything, right? Right. So you are saying that increase everybody's salary by 500, right? And let us know what that will be in 12 months, right? What will be the cumulative of that in 12 months for each person? That is what you have here, right? Now, if you remember,
I have a question.
Okay.
Does this not follow board mass?
Exactly. That is exactly what I was expecting you to say, but you did not say it. You're not asking me a question. You're actually the one that owns that question. You're the one. It was because of you that I asked that question. So, how do you think it's going to be? How do you think this is going to be evaluated?
I think it will do 500 times 12 plus, then now add it to salary.
Exactly. Now, so that is what we are trying to do. Remember, what we are trying to do is to multiply salary, right? Add 500 naira to the salary, $500 to the salary, then multiply it by what? By 12, right? But if we write this expression, so this is an expression, right? Right. So if we write this expression this way and execute it, right, it would give us the wrong answer to what we need, right? Because according to board mass, right, I want to believe everybody did board mass, right? Bracket, order, division, multiplication, addition, subtraction. This is not awful. It's not off. It's not off. Don't mind our teachers. They taught us the wrong thing. It's not off. It is order, right? Awesome. All right. So bracket, order, division, multiplication, addition, and subtraction, right? If you look at it, what we have here is addition and what? Multiplication. And if you look at it on board mass, multiplication comes before what? Addition, right? Multiplication comes before addition, which means that it will multiply 500 times 12, which will give us 6,000, right? And we'll add that to what? Salary. That is not that's not what we wanted to do. So what do we want it to do? When you want when you want to enforce this kind of arrangement, in BODMAS and you want to override the order of precedence, we call this the order of precedence. BODMAS follows, arithmetic operations follows what we call the order of precedence. Right? Now, if you want to override the order of precedence, what do? Where you want it to perform, although addition comes after multiplication, but I want it to perform addition first. Therefore, I'll put that in brackets. Right? What that means is that bracket takes precedence. Can you see? So I'm still using BODMAS to conquer with BODMAS. Bracket takes precedence. So it's going to do everything in bracket first, then multiply it by what? By 12. Right? So if we go back to the calculation that we're doing in our select statement, right? All I just need to do to correct this will be to order them like this with parentheses, right? Then if I execute this now from employees, can you see? So you have employee ID, first name, salary, salary plus 500, salary multiplied by 12, then what? 500 plus salary plus 500 multiplied by 12. Can you see? Right? So that is how we work with that. So all of those are expressions, right? All of those are expressions. This is the rule of precedence that we're talking about. It says using arithmetic operators and operators precedence. It says if an arithmetic operator expression contains more than one operator, multiplication and division are evaluated first, right? Multiplication and division, can you see, are evaluated first. If operators is in an expression are of the same priority, then you say what? Evaluation is done from what? From left to right. Let me explain that to you so that you understand what that means, right? So when we talk about priorities, right, in BODMAS, right, in BODMAS, bracket and order are of the same priority, I'm sure. Division and multiplication are of the same priority. Addition and subtraction are of the same priority, right? So which means that if you see division and multiplication before, either division and multiplication before addition and subtraction, right, what happens? It would what? It would take precedence over what? Over this one. So these ones take precedence over these ones. These ones take precedence over these ones, right? So that is one. So when you see, maybe I say salary plus what? 500 minus 1000, right? In this situation, addition and subtraction are the same. They have the same priority, right? They have the same priority. So how does it evaluate? It evaluates from what? From left to what? To right. This is on the left and this is on the right. So it does this first before it does this. Are you following me? That's the way. So if it is multiplication, if you say salary multiplied by what? 12 divided by maybe 5, right? Addition, multiplication and division are of the same priority. So what it will do is that it will do from the left before it attends what? The one on the right. So that is the way it works. That is the way that works. That is the way that works. Are you following me, please? That is the way that works, right? So that is the way it evaluates expressions. Can you see? That's the way it evaluates expressions, right? So it says you can use parentheses. That's your bracket. Parentheses, your bracket. You can use parentheses to what? To force the expression that is enclosed by the parentheses to what? To be evaluated first. Rule of precedence. Multiplications and division occurs before addition and subtraction. Operators of the same priorities are evaluated from left to right. Parentheses are used to override the default order of default precedence or to clarify what is the statement, right? So that is what we've just explained. Look at this situation now. 12 multiplied by salary plus 100, right? This result of this is going to be different from this. Look at it. The result of this is going to be different from this because here you're what? You're going to multiply 12 plus salary. You're going to it's going to perform 12 multiplied by salary plus 100, right? Meanwhile, what you want to do is that you are giving an increment of $100 on the salary right? And you want to know what that will be for 12 months. So what do? The one that we wanted to evaluate first, we'll put it in brackets. Then what? It will override the rule of what? It will override the rule of precedence, right? So that is what that does there. That is what that does there. Defining null value. Defining null value. We're going to stop very soon so that we can continue tomorrow. What says the time? I know that if I spend too much time now, people will start complaining. This is almost 7 o'clock, right? Even though I would love to push it to 8 o'clock, but it's all right. Now, defining a null value, right? So when you say a null value, say a null value is a value that is unavailable, unassigned, unknown, or inapplicable. Are you following?
Excuse me, sir.
Yes, ma'am.
Please, that one that you were saying, salary, salary times 12 plus 100. Then the second one you said salary 12 times salary plus that they are not the same. I don't understand. Please, can you explain that part?
Let me run this statement so that you can see the difference. Copy.
And sir, sorry again, if you don't even put any parentheses for you to tell it which one to run first, automatically, which is it going to run? Will it still follow the rule of odd mass?
I told you that it would. That's why I explained the what's it called there? That's why I explained the rule of similarities or priorities. B of bracket and order takes precedence over division and multiplication. Division and multiplication takes priority over addition and subtraction, right? And I said that when you have, look at this scenario where you have salary plus 500 minus 10. No, before we even go there. Now, in this scenario, right, in this first scenario, we have a salary plus 500 multiplied by 12, right? Without the bracket, it will perform the multiplication first. That is how BODMAS work. It will, because multiplication has priority over what? Over addition. So it will perform multiplication first before performing what? Addition. But if you want to overrule that, what? Override that order of precedence, then you put what you want to be executed first in bracket or evaluated first in bracket, which is salary plus 500. Right? Now, salary plus 500 is actually what we want to do. What we are trying to do is increase salary by 500 and multiply by what? 12. 12 is for each month of the year. We have 12 months in a year. So we want to know the cumulative of what the annual salary is going to be. That's basically what we're trying to do there. Right? So for the example in the slide, right? For the example in the slide, we are saying the same thing. It's the same thing, except that we are saying that if we do this first one will not give us the annual salary. Because what the first one will give us is it will give us annual salary plus 100. But what we are trying to do is not annual salary plus 100. What we are trying to do is that increase the salary by 100, then what? Multiply by 12 to give us the annual salary. Do you understand now, Madam Anita? What we are trying to do?
Yes, sir.
You understand it now, right?
Yes, we'll do the salary plus 100. Put it in
Yes,
bracket.
we'll do the salary plus 100 first. We'll put that in brackets, then
now multiply by 12.
Yes.
Okay. But you wrote 12 multiplied by the salary first. So
no, that's yes. What I'm saying is that that's why I said that this statement would not give us the same result.
Yes.
Exactly.
Okay. Okay. Thank you.
All right. So I don't need to run that anymore. Right. Defining null value. So we're saying that null value are values that are unavailable, unassigned, unknown, or inapplicable. It says null value is not the same as 0 or a blank space. Right? Null value is a value that is not known. It is unassigned. It is unavailable. It is inapplicable. Right? And what we are saying is that when you see 0, when you see a value of 0 and when you see a value of 0 and blank space, they do not mean the same thing. Right? Now, what does that mean? I'll give you an example. In an organization, right, there is there are people who collect commission percentage or who collect commission, right? A percentage of their sales, right? And that usually applies to people in sales, people in marketing, or maybe social media marketing, marketing generally and sales, right? Um, every other department majorly does not really get commission, right? What they get is a salary, right? Now, what that means is that in that column, and there's a column called commission percentage column, right? It means that on that column will contain what will allow for no value because not everybody in the organization collects commission. Are you following me? Now, because not everybody collects commission, doesn't mean that every other person that collects commission, that does not collect commission, we're going to say their commission is zero. No. Commission being zero is different from commission being null. Now, and you're going to see it in this example. Commission being zero is different from commission being null because commission being zero means that if I want to calculate their annual commission and all of that, what I'm going to get is zero because anything you multiply by zero will give you zero, right? And also, the person who does not collect commission today can be transferred to sales or marketing department tomorrow and begins to earn commission. Are you following me? So therefore, we use null value. Null value is used to define a value that we do not have a value for yet. It's used to define a value that we do not have an actual value for at the moment. So we use null value to represent that, right? And we want to see how null value plays its role in arithmetic expressions, right? Take for example, if we write this statement, right? Let's look at it. If I come here and I say select employee underscore ID, right? First underscore name, salary, multiply by 12, multiply by commission underscore PCT. The commission underscore PCT column, let me bring it out. So let's say salary, that you understand what I'm saying. Salary, then commission underscore PCT. Right? So from what? From employees. For me. Now, if we run this statement now, now look at it. Look at the result. I want you to look at the results. Right? Employee ID, first name, salary. Can you see all of them have salary? Right? All of them. All of them have salary. But I want you to pay attention to the commission percentage column, right? Pay attention to the commission percentage column. If you look at it, the first set of people do not receive commission percentage, right? So the question is why? Why don't they receive commission percentage? Then you all of a sudden you begin to see people who earn commission percentage. Can you see? You begin to see people who earn commission percentage. Then all of a sudden we don't see people. The rest do not earn commission percentage. So why do these people earn commission percentage and the others do not earn commission percentage? So let me introduce to you how we used to know. So we say job underscore ID. Job underscore ID would help us what differentiate, right? So if we run that statement again, we run this statement again, we will see that it would help us differentiate those who receive commission percentage. So if you look at it, these guys are in the first set of people are in admin, IT programmer, financial accounting, purchase clerk, stock manager, and all of that. Then the people who receive commission percentage are sales manager, sales rep. Can you see sales manager and sales rep? Can you see? Then all of a sudden, stock clerk and every other person do not receive commission percentage. So you see that it's only a single department that is earning what? That is earning commission percentage. Now, if you look at the expression that we gave, salary multiplied by 12 multiplied by commission percentage. So which means that we want to analyze what will be the commission percentage of each person, of these people at the end of the month, I mean at the end of the year. How much would they be earning at the end of the year? How much would they be earning at the end of the year? Now, that's why we're saying that salary multiplied by 12 multiplied by, for those who do not receive commission percentage, you have NOB. Can you see? So what you have is salary multiplied by what? 12 multiplied by NOB. Anything multiplied by NOB will give you null, right? Anything multiplied by null will give you null, right? So, and for those who receive commission percentage, can you see? We're saying that this is their what they are going to be collecting at the end of the month or at the end of the year, right? So we're saying that salary, so for them, they have a value 0.4, 0.3, 0.3, 0.3, 0.2, down like that. So for those who have values in their commission percentage column, they would earn that, or this expression will be evaluated for them. And for the rest who do not earn commission percentage, what happens? They would not have a value for that expression. I hope you're following, right? So that is the essence of null value. That is the essence of null value, right? That's the essence of null value. Are you following me? Now, we want to define a column alias, right? We want to define a column alias. And let me see.
Sorry, sir. I want to
Yes.
ask you a question.
Please go ahead.
Please, for that commission percentage that you're talking about, what of if the question you are giving the exact commission to multiply it with?
In that situation, if you are given, so if you are saying that this is it, perfect. You see, I like that we're all participating. So we're saying that what you just asked me is we use what we call NVL. I will actually talk about it later, much later. We use NVL and NVL2 and Qualis, right? That is how we deal with null values, right? How we deal with null values. We use NVL, NVL2, Qualis to deal with that situation. And what you are saying is that it's like you are using switch in our programming, that if this value is this value, then use this for this person. If this value is this value, is use this for this person. So when you
Exactly.
exactly, let me show you an example. Just give me a minute. Give me a minute.
Please, what question?
Yes.
Like what did she ask? I didn't get the question.
Oh, okay. She's asking that how do you deal with, you know, that these people, some people on database do not receive commission percentage, right? She's now saying that in the case where you want to give them value, and you're saying that for everybody who does not receive commission percentage, use 0.5 for them. How do you do that?
Okay.
Do you understand? How do you do that? That's what she is asking us. Just give me a minute. I'm trying to work out a possible analysis for that. Right. So I was saying that hold on. So we'll just say NVL. Hold on. I hope it works. NVL. Hold on, I'm coming. Try to look through my code to be able to get the appropriate function for it. All right, so you are saying that, look at it. You are saying that for those who do not have commission, for those who have commission percentage, perform this, right? So we're using NVL. Are you following me? We're using NVL to say that for those who have commission percentage, let's do this appropriately. That will be, how do you calculate commission? Hold on. Salary plus right? Salary plus, this is for commission percentage. They are saying that for those who do not receive commission percentage, salary multiplied by 12. All right, so let's run this now. Everybody should have a value now. MVL does not work in MySQL. Why? Why? Coming. Okay, in MySQL, what we use is the if null value, right? This is a push into front. Come in, just let me solve this. Salary multiplied by this. Okay, so salary multiplied by just give me a minute. Salary multiplied by commission percentage. Right, so we're saying that if they don't have commission percentage now, hold on. If null, commission underscore PCT, comma, what do we do for them? We do salary multiplied by 12. Hold on, let me try this. Okay, the code is still not running. Basically, what we're trying to do is run an expression that allows for, usually what we do is NVL, we use NVL, but in for those who have no value, if it is no value, then perform this for them, right? If I don't get this code to this night, I'm going to write it to this night so that I can present it to you tomorrow. Right? I don't want to waste our time trying to figure this out, right? But we're almost there actually. It's just me trying to understand where to put my if now. Let's try this again. Still not working. All right, I'll figure it out, right? But basically, this is how we solve it. We use if null, or we use NVL. NVL, we use coalesce, right? We use coalesce. There are several functions that we use to solve that issue, but I'll show us that probably tomorrow, right? I'll show us that probably tomorrow, right? So we stopped at column alias. I think we should stop here today so that we don't over push it. How many hours of class have we done? Done over 2.5 hours of class. So any question so that we stop here? Any question so that we can continue from here tomorrow? Continue from here tomorrow. Please, I would make sure that I leave church early tomorrow so that we can have at least 5 hours of class tomorrow. If we can start by 3, we'll end by 8. So please prepare. Start by 3, we end by 8. We have a lot to cover and we're dropping the ball by slacking in time. So please let us all make sure that we come to class early tomorrow. Yes, I can hear you.
Yes, I you said we're going to start by 3 and end by 8. Some of us are still in church by 8. So why don't you keep 3 and start by end by 7? Because Monday is a very busy day.
Some of us are still in church by what?
By 3 now.
Who is talking? Are you the one preaching in church? Who is that? Lola. Lola.
So you don't know my church now. You don't know whether next week is Thanksgiving. I mean tomorrow.
Well, so you're always in church by, you're still always in church by 3.
Oh no, that's not true, but like I'm just saying that you can start by 3 and end by 7.
Well, I usually start by 2, right? But I'm not sure that I can make 2. That's the challenge. I usually start the last batch that we did. We start by 2, we end by 7 or 8. But irrespective, if we can do 4 hours, 4 straight hours, that's fine. 3 to 7, that's fine. That's fine.
All right, thank you.
All right. Any question before we end it up today? Any question?
Hello, sir.
Yes, ma'am.
I didn't get your feedback for my homework, the assignment I submitted.
I gave feedback for let me show you. Let me show everybody. I gave feedback for everybody. I don't know this one that everybody is saying that I did not show them feedback. It's becoming something else. I gave feedback to everybody. Check your mail. I gave feedback on all the assignments. I'm even surprised I was saying that we didn't get the feedback. John, did you get the feedback? Vivian, you got the feedback now?
Yes, I got the feedback.
Yes, I did, sir, and I gave you.
I saw you that you replied, you acknowledged it. I gave the feedback to everybody. Microsoft. Please, Lola and Madam Anita, please check your mail again. I think I gave the feedback to everybody. I'm going to look at it again.
Yeah, I'll check again.
Hold on. Class exercise. Sent. Look at it. I gave a feedback. What was this? Did I? No, this is September. Coming 2, 3, 4. So look Vivian. Wow. I thought I did. Apologies if I did not. I thought I did. I really thought I did. Wow. I thought I did. So I only acknowledged how many people want to play. Wow. But Madam Anita, I sent you a feedback. Right. This is yours. I think it's just Lola that
I
I
didn't get a feedback as well.
But
I used to
Trisha,
do.
did you submit?
Yes,
I'll check
twice.
again. I'll check again. Apologies. I thought I because yesterday I did everything. I didn't know. Maybe they didn't send, maybe network. I'll check again. I'll check my outbox to see. I attended to every question, every submission. I attended to all the submissions, and I'm surprised that we didn't get my feedback.
So you can
Um,
resend it to.
yes, I will.
Okay.
And also, I'll give feedbacks on the assignments we did, the classwork that we did today as well. Yes, I said that I was going to answer those questions, right? So let me quickly do that, then, so that you can. Let me quickly just answer those questions so that before we go. So, all right. So, we said what is the function of constraint, right? I think most people got it, or most people have an idea of what it is, right? But basically, constraints are used to enforce rule at table level. That's what they do, right? I would hold on. Constraints are used to enforce rules at table level. That's what they do. Constraints, yeah, are used to enforce rules at table level. Basically, what we are saying is that we use them to enforce rules on a table, right? We'll use to enforce rules on a table. So let me just do it that way, right? Use to enforce rules on a table. That's what constraints are used to do, right? Most people got this one. The difference between primary key constraint and unique key constraint is that primary key primary key is compulsory and must be unique, right? Must be unique. While unique keys are not compulsory, but if they are going to have values, they must what? But must be unique, right? That is that. What is the function of the alter table, right? The alter table is used to make changes on a table, on the structure, the structure of a table. So we use them to make changes to the structure of a table. What is a relation? A relation is a relation is used to store data in rows and columns. And I've told you that a relation is also known as a table, right? A relation is also known as a table, right? It's used to store data in rows and columns. And the last one is, what is a DBMS? A DBMS is a database management system that is used to store, retrieve, and manage data in the database. That's basically the answer to all of those questions, right? That's basically the answer to all of those questions. But most of us performed well. Now, if you look at it, the way I answer these questions are a bit different from the way a few people came close, right? But if you look at it, there are some words that are very peculiar that are needed in the answers. So in the first one, it says enforce rules is what we're actually looking for in that part. They used to enforce rules on a table, right? Primary key and compulsory. Almost everybody got that one. I think because I've overflogged that. Primary keys are compulsory and must be unique. Unique keys are not compulsory, but they must be unique if they have a value. Yes, then this one, alter table, most people got it, but not in the exact way that I would want it, right? It says to make changes. So that's what most people said to make changes, right? But you're not making changes to the content of the table. So you need to be able to tell us where the changes is happening, right? It's a DDL statement that is used to make changes to the structure of the table, right? So structure of the table is very pertinent in that part. Then relations, yes, is stable that helps us store data in rows and columns. And DBMS, yes, we know that DBMS is the management system software, right? Database management systems, but you didn't tell us what it does, right? Which is to store, retrieve, and manage data in the database.
Sorry, sir.
Yes.
You said for the DBMS, you did not include modified data as well.
I didn't include what?
It also modifies data.
Yes. Okay. Modify. Sorry. Yes, we can add modify to it as well. Yeah. Store, retrieve, manage, and modify data in the database. Yes. Although I have put manage, modify under manage, but it's all right. Modify and manage data in the database. All right. So that is the answer to those questions. Tomorrow I'll be giving you another set of questions, hopefully, so that they can prepare you, right? And just continue to prepare. I didn't do this for the people in the first step, in the first cohort, right? But we're getting better. But gradually you discover that you're prepared, you're fully prepared. So, any other question before we wrap up today's class?
Sir,
Yes, ma'am.
please, this class that we just had now, can we get this thing today, the video? The
The video.
located there.
Yes, I will do my best to be able to push that today.
Okay, sir. Please, I want to go through it before tomorrow's class so I
All right,
can understand it.
I'll do that. I'll do all my best. I'll do my best. Any other question?
Okay, thank you.
Yes, ma'am. All right. So, if you do not have any other question, thank you for coming to class today. It's really great having you in class. Everybody in fact, today is a beautiful class. Everybody is present. Everybody is present. Everybody is present. Please, please, please. Hopefully by after this, I have another training coming up, which is data visualization for those who are interested. But please do not keep what we are doing here to yourself. Help me advertise Avita to people. Tell people about Avita. Tell people what we're doing so that they can register for upcoming or coming events or coming trainings. Right. That way, you are also adding value to us as we're adding value to you. Please help us advertise. Tell your friends, tell your colleagues, tell your church members, your mosque members, everybody that needs to learn IT, that are interested in learning IT. Tell them, just point them to our direction. We will take it up from there, right? Thank you. Thank you for coming. Do have a wonderful evening. You can exit class now.
Yeah,
God bless
good
you.
night, sir.
Have a wonderful night, everybody.
Good night, sir.